This is the 611 Group Replication Project. We are EST2. I'm Caitlin Barron,
Corinne Sevenish,
Lauren Long,
Oceana McWay,
and Kelsey Kirtley.
In the original study, the research of Dr. James Levine was on health risks of prolonged sitting that inspired a study on how to decrease prolonged sitting in office employees. This in turn can also lead to death from cancer and cardiovascular disease. Even by moving during your daily routine, you can burn more calories and decrease risks to fatal illnesses. This study was published in 2016 by Green, Sigurdson, and Wilder. The purpose of this study was to determine whether or not implementing a prize incentive would increase physical activity in moderately active adults. Another purpose was to decrease prolonged sitting and increase the number of calories burned and steps taken in a day, therefore preventing chronic illnesses and promoting a healthier lifestyle. The participants of this study included 5 females, which the age ranged from 23 to 26. All the participants were full-time employees, and they were enrolled at least part-time in graduate courses and were moderately active. The setting varied across participants as well as varied across different cities. Some participants were in Bloomington, some participants were Carmel and Crawfordsville. It also varied between 2 different workplaces. Another setting we used as a medium of communication during the study was Google Hangouts.
The materials for this study included an accelerometer. Participants used Fitbit and Apple Watches. They also used phone applications that corresponded to their device, such as the Fitbit app and Apple Watch app. We also used a prize generator app. We used a reinforcement table, data collection table, and computer software. The behavior definition that we used defined physical activity as any bodily movement produced by skeletal muscles that resulted in energy expenditure. An example of this would be walking, running, swimming, lifting objects, or doing sit-ups. A non-example would be laying in bed or sitting in a chair. The data collection method we used for this study was frequency of steps accomplished each day. Data was collected by each participant on their own. They were responsible for calculating their individual step count as well as their daily step goal. Step goals were figured by adding 500 more steps to the previous day during the intervention. Participants were responsible for turning in group messages on a weekly basis showing their data. This shows an example of one of our participants wearing a Fitbit, as well as a weekly data snapshot that was turned into the group.
During our study replication, we conducted 2 separate baselines, one prior to the intervention and one following the intervention. Prior to the baseline, each participant was to decide their 3-level reinforcers, low, medium, and high. An example of a low reinforcer would be verbal praise. An example of a medium reinforcer might be a coffee from Starbucks. And then a higher reinforcer would be a new set of workout clothes. We took baseline data for 7 days, and as long as each participant wore their accelerometer, they were eligible to participate in the opportunity to earn a prize draw. No goals were set during the baseline phase, and the intervention contingencies were calculated based on the data from our baseline. So our 5th highest step count day plus 500 would be the daily step goal for the first day of the intervention phase. During the intervention, each participant had an opportunity to earn a prize draw daily. The initial step goal was the 5th highest step day from baseline 1. Then throughout the intervention, the daily step goal for the next day was calculated by adding 500 steps from the previous day's achievement. Each participant was eligible to receive a prize draw as long as they met or exceeded their daily step goal. Due to everyone being in different areas, we could not conduct IOA. However, for this study, if we were to conduct IOA, we would use exact count per interval IOA. The formula for that would be the number of intervals that were at 100% IOA divided by the total number of intervals times 100. For this formula, one interval is equal to 1 day, and the entire study lasted a total of 21 days. For treatment fidelity, we use daily check-ins through Google Hangouts. We relied on participatory honesty. We took screenshots of our progress and data daily, which helped to ensure that everyone was honest. And then we also would refer back to our operational definition just to make sure that everyone was still following the same definition throughout the study.
So at this point in our study, we have added in each participant's graphs, which depicts the data from both the first and second baseline as well as their intervention phase. For this specific participant, her first baseline phase began as a slight increase in physical activity. There's a small dip and then it increases once more. However, it is fairly stable compared to if we were to elongate or shorten her baseline data. Her intervention phase, however, is not as stable. It has an initial increase towards the beginning of the week, and then as you progress towards the middle, behavior decreases, and this could be an example of a confounding variable, such as the end of the week approaching and the weekend. But overall, this specific participant's average amount of steps during both baseline phases turned out to be higher than they were during the intervention phase. So we've come to the conclusion that for this specific participant, implementing a prize intervention was not an independent variable for a change in behavior, or at least a change in behavior in the direction that we wanted to see it. As far as Caitlin's graph, her first baseline phase, her steps increased throughout the entire baseline, so we couldn't gather a stable baseline data. But once you get to her intervention, she does have an increase in behavior for the first half of the week, and then we start to see a major decline in behavior towards the end of the week, which once again can be a result of a confounding variable. Unlike Oceana's graph, however, Caitlin's second baseline has a large amount of decrease in behavior, and that could be a suggestion of experimental control with our independent variable. However, it would be best to replicate her intervention phase once more and see if there was a trend in her behavior increasing upon implementation and decreasing as we withdraw that. Corinne's graph, much like Caitlin's, has an initial increase in the intervention phase. However, we do see a large amount of decline towards the end of her intervention. And like Caitlin, we also see a large decline in the second baseline phase. likely this is due to a confounding variable of just the week coming to an end. So we see that large decline in the intervention phase. Kelsey's graph is much different than the ones we have seen thus far. Hers is very variable, both in the baseline and intervention phase. At first, we see a high amount of activity in the beginning of the week. And then as you get to the middle of the week, we have a large decline, as well as her goal declining because of the way that our study changes the step goal based on the amount of steps that you achieved the prior day. And then we also see a small incline and it goes back down. So we weren't able to actually gain a stable amount of baseline for Kelsey since it is so variable. So we couldn't really come to a conclusion that the intervention played a part in a change in her behavior at all. And then lastly, Lauren's goal, or Lauren's graph, portrays very stable data in all phases. So her first baseline and second baseline look very similar to her intervention phase. We don't see an increase or a large decrease in behavior during intervention. So at this point, it would not be accurate to conclude that our intervention actually served as an independent variable for a change in behavior, because there was very little, if any, change in behavior at all during the entire experiment. And then we have added a portion of the graphs from the original study. They originally had 10 graphs from their subjects, but we added the first 6 so that we can compare them to ours. So here we see subject 1's graph. Their baseline data is also not very stable. However, we do see an increase in the intervention phase, and a decrease occurs once again in the baseline phase, which actually does suggest that implementing a prize incentive does count as an independent variable for changing that behavior. And the experimenters in this subject's case had experimental control over that independent variable. However, we don't see that pattern with very many other subjects. It seems as if most graphs are very variable, much like Kelsey's. So it's hard to conclude that implementing a prize incentive really does motivate individuals to increase their activity on a daily basis.
And these are our averages and ranges from baseline 1, intervention, and baseline 2. As you can see, they're variable, as Oceana has mentioned from the graphs. We cannot conclude that the intervention was an independent variable for the prize incentive. And just some limitations of the study. We were unable to meet in person, and so this goes back to our IOA, and we were not able to keep track if we were wearing our Fitbit or Apple Watch each day, or making up our data or so forth. And we were only able to meet and communicate via Google Hangouts. If we had more time, we could have replicated the study for a longer period of time, which would have allowed us to further analyze the data. But we had such a limited amount of time to actually conduct this study. Due to little time, we also had the same amount. We had to replicate for each participant the same amount of baseline, the same amount of intervention, and the same amount of baseline 2. So each phase had to be the same amount of time for each participant. If we would have had a longer amount of time, we could have replicated shorter phases and longer phases for each person. Another limitation was that 3 individuals had Fitbits and 2 had Apple Watches. And then another limitation was the lack of motivation due to little to no reinforcement, and the study is designed to reinforce a lower amount of activity. So, for example, if, for instance, you got 100 steps one day, you only had to get 600 steps the next day, and then so forth and so forth. Whereas if someone got 10,000 one day, they would have to get 10,500 the next day. So it just varied as far as individual. And going back to the previous statement, the reinforcement wasn't immediate. And then each individual was in charge of their own reinforcement. So we weren't able to keep track of people giving themselves reinforcement throughout the week or giving themselves reinforcement at the end of the week. In conclusion, the prize incentive really didn't prove to be an independent variable for this experiment for the participants, and some participants exhibited a spike in the behavior during intervention phase, yet no increasing trend across participants. And behavior may have been controlled by confounding variables, whether it was during the weekend, schedule changes, moving, illness, or so forth. I know, for example, Oceana was in the process of moving during baseline, and Kelsey, was sick for majority of the intervention phase. And without further analysis, this is not a conclusive set of data. And this is our study that we referenced throughout this PowerPoint. And thank you for watching and listening to our study that we conducted.